Good afternoon, students. I'm having another video today, and that is from unit number 3, which is first year classification of elements and periodicity in properties. Look here, I'm going to give you some super concepts, okay, and you have never heard this, I can guarantee it. Okay, so without delay, let's start the videos, right? And the first question of the session, here it goes. Okay, it says that the electronic configuration of two elements x and y. Okay, two elements are there, one is our x element and another one is our y, and here we are having what? 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2, and another element we are having what? This, the 1s2, 2s2, 2p6, 3s2, 3p5. Count the total number of electron here, or without counting also we can do it. Look, 4s2, as p orbital is completely filled, right? 4s2 means what? 2 electron in its outermost shell and its s orbital. That is what? Definitely it belongs to s block element, right? So 10, 10, 20, that is what? Definitely calcium, and it can be what? Calcium 2 positive. It written here, ionic compound. Next, y, 10 plus 7, 17. So 17 means chlorine, right? So chlorine can be what? Negatively charged. So what is the salt formation here? So this, it can be written as what? X2 positive, and it can be written as y. So as we are having ion, right, with us, so we have to write what? Charges of the ion. It's 2, 1. We don't have to write negative or positive, and just what? We have to cross multiply the value. So x into 1, x into 2, sorry, y into 2, y2. So this is the formula of the compound, that is what? X, y2. Okay, so this is the concept here. We are talking about the outermost electron, right? Okay, students, we are looking at the outermost electron. So to fulfill the octet group, it will what? Donate 2 electron. To fulfill the octet group, it will have what? 1 electron in its outermost shell, right? So it is what? 3p6. So if taking 1 electron to single negative, so positive and negative. So I have solved this question also here, so you can have a look on this solution and you go up to this. Okay, so okay, the next question is this: an element x belong to 4th period, okay, 4th period and 15 group of the periodic table. Okay, 1, 2, 3, 4th period and 1, 18, 17, 16, 15. Okay, now what says, which of the following statement is true about this element? Okay, now look at it. First of all, let us find which the element is. Now if you talk about 18 block element, so what is the element, or what is the number, atomic number of this element? Let's try to find out, otherwise we can't tell these things. We have to go after what? Electronic configuration of this particular atom here. So it is 4 many what? If you talk about this noble gas element, so what we will get to know, that 1 here is what? 2, right? 8, isn't it? Then 18, then what? 36. If it is 36 and 18, 36, then it will be what? 35, it will be what? 34, and it will be what? 33. So here in the question, whatever it's talking about, the atomic number of the element is what? Your 33, and here it is what? 14, 13. So what we know, if it is the thing, then what is the electronic configuration of this atom? It's belong to nitrogen family, and nitrogen family is what? Your ns2 np3, isn't it? And if it is talking about the 4th period, right, so it will be what? 4s2, 4p3. So here it is what? 33 means what? Here it is 3d10, it is filled. So 3d orbital is what? Completely filled. S orbital also what? Completely filled, but p orbital 4p3 means what? 1, 2, 3, and it is what? Half filled. So which of the following statement is correct? So it is correct. Okay, it has an half filled p orbital, obviously, which we have find out now, and completely filled what? S and d orbital. So look, it's a super trick, isn't it? What you have to do, you have to know these things. You have to know the means what? Call your 18 group element first. Okay, so you can start from the end part. Okay, it's amazing thing. Okay, I'm having another question here, so I will go more tricks with this. I have solved this question for you. Look at here. Okay, so I have written here 18, 17, 16, 15, 13, 14. So this is a p block element, right? Now it's talking about what? It's talking about what? 4th period. So 1, 2, 3, 4. It's belong to definitely what? We will talk about what? Krypton, right? So 36 and 15 group. So if it's 8 in 4th If it is 36 in 18, then what? In 17, 35, in 16, 34, in 15, 33. So if it is 33, then what? N/2 Np3, then that is what? Fourth period. So 4s2 4p3. So this is how we have find out. Okay, so you just have a look at the solution. Okay, students. Okay, the next question, here it goes. It says that the element of the fourth period of the periodic table having maximum number of unpaired electron in its ground state. Okay, calcium, right? Calcium 20 means what? So it's belong to what? Alkaline earth element. It will have what? Ns2. So complete electronic configuration. So rest of the what call your orbital will completely fill, right? So here it is also fill, no unpaired electron. Then what? Zinc 30, so 3d10, it is definitely, and 4s2, here also no unpaired electron. Arsenic 33 means what? We have just right now we have solved this question, right? So 33 means what? 4s2 4p3. So here we can have how many unpaired electron? In 4p3 1 2 3 unpaired electron, right? Then chromium 24 means what? We can write 3d5 4s1. So this is the outermost but stable one. It is what? Stable one. So what is the number of unpaired electron? 3d5 means what? This 1 2 3 4 5 unpaired electron, right? 5 unpaired electron, and 4s1 means what? 1. So 4s in 3d. So total 6 numbers of unpaired electron. So I think you guys know how to write the electronic configuration, right? So this is what I have solved for you. Look at here. So all orbital are filled here in case of your calcium. So unpaired electron no. Zinc also all orbital are filled, but arsenic 33 what? It is 4s2 4p3. So in 4p3 we are having what? 3 unpaired electrons. So it will look like this. So here it is also. So this one. So chromium has what? Maximum numbers of what? Unpaired electron, and that is what? 6. So this is the interesting question. Okay, I am telling you. Okay, this is another question. This is the interesting one, means easiest one. Okay, increasing order of the ionic size for the ions F negative, O2 negative, Na positive, and Al3 positive. Okay, so here is the trend. It's a simple one. Look, first of all, you know the size of anion will be greater than the neutral atom or parent atom, neutral atom. Okay, then what our cation. Now, logic is that more the value of negative means this what call a charge, negative charge means larger size will be there. Okay, so and this neutral atom is intermediate between them, and regarding cation, more the positive charge, so what more smaller the size or radius of the atom. So means, so look at here in the D option, it is what? Aluminium 3 positive. It has very smaller size than F negative, then what? Na positive, then Na positive, then F negative, then what? O2 negative. So O2 negative has a larger size because it has more negative value, then F negative, then Na positive, then what? So which is the correct option here? I think option B is the correct one, right? So here I have going through this. So this is the concept part. Okay guys, these two is the concept part. You just try to go through this thing. I have written these things very clearly here in a very simple language. Okay, larger the value of negative charge, bigger is the ion. Larger the value of positive charge, smaller is the ion. Actually it always asks in case of our isoelectronic species. You don't have to count for electron. If this type of questions are giving, then definitely the ions which are giving, they all are what? Isoelectronic in nature. I think this is the important question for you, and I have seen that you know these questions are often asked in the numbers of examination. Okay. Okay guys, another question here which says that which transition involves maximum amount of energy. Look, M positive to what? M2 positive. Mean what? It will involve energy, right? Because we are eliminating the electron. So what? We are ionizing it. So ionization potential would be there. It requires electron. But look at it, option B, it says what? M2 positive, then we are trying to make it what? 3 positive. Means what? Look, already it is 2 positive. We have already eliminated what? 2 numbers of what? Electron there. Okay, and we are again trying to remove what? Another more electron. Means this is what? Third ionization energy. And what we know, you know, third ionization energy is greater than second, then what first? That means what? If it is di positive, then it is what? The size is smaller, right? And from a smaller atom, ion or atom, if you're trying to eliminate the electron, you know, it requires more amount of energy. I think this will be the correct question, guys, you know, because it is di positive, and if you're trying to remove electron here, so it is much more, you know, required lots of energy here. Okay, so look at it. Here I have given the option. Look, this B option, right? M2 positive involves how many steps here? First of all, it was M. Think of it. So it requires energy. Here also it requires energy. So here what? It is maximum. So successive ionization energy what? Increases. So, and this is the concept, guys. As the size increases, the attraction between the electron and nucleus also increases. So the size decreases. So it is very difficult to remove electron from in what? A smaller size. And so this is the main concept we have to. And interestingly, this question, the same question, it has been asked in numbers of examination. I have sent, so look at this, it is asked in AIMS 1992 also. Okay, guys, I'm telling you, this is the interesting question. It's going to be an interesting one. Here I am going to tell you the super trick here. It is written the electronic configuration of the element which is just above the element with atomic number 43. Interestingly, 43. Okay, in the same periodic group, it belongs to same group here. So which is the what call your means what is the atom here, what is the electronic number of electron here or atomic number, and what is the electronic configuration among this. Look, I have already told you that I will do another question, you know, the super trick is here. Look, what you try to do, you know, in this type of questions, I have got numbers of questions. The same question was there, so that's why I have not given it. I have not repeated the numbers of questions, the same question here, but I have taken one of the example here. Look, what you do, you know, you try to remember up to 5th period. Okay, 6th and 7th, this is what you no need to remember that one, but actually, so you try to remember the atomic number of first, second, third, fourth and fifth period, okay, from the starting and the end one, and try to know what is the number of atom, total number of atom there, total number of atom. Now it is asking for what? 43. Above 43, what is the atomic number? So you have to count, right? So what you will do? 43 belongs in what? Fifth period. If it is one 37, look here, it is what? 37, right? So 37 means first period, isn't it? Sorry, first group. So 38, 39, 40, 41, 42, 43. So in 43, which group it would be there? So look at here, I have drawn it here, right? 37, 38, 39, 40, 41, 42, 43. 43, what is the above element with atomic number? 25. 25 means what? It is manganese, right? So if it is 25, then what is the electronic configuration? 3d5, 4s2. Isn't it isn't super tricky, right? So you just have to know this. Whether you count from this side or this side. Look, what we have done, right? It is 43. How many electrons are there? 18 element. So in fourth period also it is 18 element. So above 43 means what? It belongs to fourth period. So what we are doing here is that, so 18. So what? 43 minus 18. So what you are getting? You are getting 25. Okay, this is, so it is the element with atomic number 1. 43 minus 18 equal to 25. Okay, so this is how we can solve this question. And I am telling you, you try to remember these things. Okay, in every where you will means you are going to love this. Means you have to know this. Okay. So this is the super tricky one. Okay guys, look, this is the same type of question is here. If the atomic number of an element is 33, so it will be placed in the periodic table in the first group, third group, 15th group or 7th group. 33. Look, noble gas, right? 36, 18. So 17, 16, 15, 14, 13. So 36 money, here it is 35, here it is 34, here it is 33. It belongs to what? 15th group of the periodic table. It's very simple, right? So you have to know these things actually. Okay, so this is what. Okay, so provided what I am written here is that to remember the tips provided in the question number 6. So you go at the question number 6 here. Okay, so that is what I am talking about. Okay, look, another question guys. An atom with electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. 3d3, 4s2 means what? 33? Sorry, 23, right? 23, isn't it? 10, it is again 10, 20, right? It is 3, 23. So 23. So it can be placed in group what? So 23 means what? 19, right? 19. So 19, 20, 21, 22, 23, right? So 19 to belongs to what? Here above this is what? 11, then it is what? 3, then it is what? 1. So 1, 2, 3, 4. Fourth period, isn't it? Fourth period. So it is first group, it is second group, third, fourth, to fifth. So it belongs to what? Fifth group. Okay. So this is how you can solve. Look at it. First, second, third, fourth, fifth. So atomic 19, 20, 21, 22, 23. Okay. So 23 belongs to what? Fifth group of the periodic table. So right, it's these things are the super tricky things. Okay, you have to know this. So you will try to solve, means you will able to solve this type of questions, in a fraction of a second. Okay. Okay, look, this is the easiest one. To select the ion one having largest ionic radius. Look, it is A2 positive, A2 negative, A positive, A negative. So if you arrange them, then it will be what? A2 negative, largest number of an ion, right? Sorry, negative ion, and A positive, then this. So which is the largest ion? This. So it's very simple. So when, look what I have written here, this is the what concept. When electrons are added to an atom, it results in what? Lesser attraction between the nucleus and that electron. So what? The size of that particular ion will what? Increases. Okay. Okay, the next question, which of the following is the correct order of electron affinities? I am telling you, this question may confuse you guys in examination. But you know what? Electron affinity, or it can be written as what? Electron gain enthalpy. What happens, as we move down the groups, the electron affinity, it will what? Decreases as we move down the group. That is what? If size increases. So electron affinity, what I have written here, it is the amount of energy, okay, release when an electron is added to it. So I have going through numbers of concepts here, this one, look, left to right in a period, okay, increases because size decreases, right? Top to bottom in a group, it is what? Decreases because size increases. But you know what, here this is talking about what? Halogen, right? Fluorine, chlorine, bromine, iodine. If you generally talking about the thing, then it should be what? Fluorine greater than chlorine, then bromine, then iodine, right? As we are talking about the decreasing order. But among fluorine and chlorine, there are some exceptional cases. Okay, chlorine has more electron affinity than fluorine. What it says that fluorine has less electron affinity than chlorine. It is due to the fact that when an electron is added to fluorine, the electron goes to what? Smaller energy, that n equal to 2. So when it happens, the electron, which added electron and the electron already present here, so they will undergo what? Repulsion. Okay, but in the chlorine, what? The electron will go to what? N equal to 3 energy level and occupies a larger region of space, leading to what? Much less electron repulsion. So it will, chlorine will have what? More electron affinity than what? Your fluorine. Okay, so this is the correct order. Okay, chlorine, then fluorine, then bromine, then iodine. Okay, so this is the option B is the correct one. You try to go through these things very carefully. Okay, whatever I have given here, you try to go through these things. Okay, so this is the main concept here. Okay, and you don't try to forget. So, and this question again, I am telling you, I have written here, I think it is also known as what? Electron gain enthalpy. So it may ask as an electron affinity or electron gain enthalpy. Don't confuse with this. Okay, students, another question here. The set representing the correct order of the first ionization potential is. This is asked in IIT examination. So regarding ionization potential, or ionization energy, as we move down the group, what happens? The ionization energy what? Decreases, because ionization energy is what? We are applying a supplied amount of energy to remove electron from an outermost shell of a gaseous atom. So look, when size increases, what happens? The nucleus and the electron, they will have what? Less attraction. So less attraction means what? This atom is free. Okay, this atom is free, so free to remove. So when means what? It requires minimum amount of energy, but as they are closer or the size is smaller, so this electron will present at the inner shell, so more attraction with the nucleus, so we require what? Higher amount of energy. So it should be in a regular manner, because as the size increases in regular manner here. Okay, so sodium, potassium, so this is what? Wrong. Beryllium, magnesium, calcium, this is what? Second group element, isn't it? Boron, carbon, hydrogen, this is talking about period. So this is what? It should be greater than of nitrogen, not of carbon and boron. So I think the second, this group element is the correct answer. Okay, so beryllium, right? Magnesium, then calcium, right? 4, 12, 20. Okay, so this is what I have given it. Okay, second group element and all that. Okay, students, the another question, the number of d electron retained in Fe2 positive ion, okay, atomic number 26. So if when it is Fe, it is what, 26. 26 means what is the outermost electronic configuration? 3d6 4s2, definitely, right? And what it is talking about, Fe2 positive. Fe2 positive means what, 24. If it is 24, then what, 2 electron will remove from this 4s, so what electron will have? 3d6. So 3d6 means what is the number of electron retained in the d orbital? It retained what, 6 electron, isn't it? So this is what, okay, so 6. So okay, so then, so these are the some of the questions, you know, that belongs to your what, group 3, sorry, unit 3, okay, periodic properties and of element and all that. So you try to go through this type of questions, you know, above this atom. I have already told you how to find the position, right? If you are not knowing, you go through this what called question number 6 again and again, okay? You try to go through that particular concept again and again, then you will the question will be very easier for you, okay? So students, if you like the video, you try to share the video among your friends, okay, those who are preparing for your NET examinations. Then means if so I think they can also be helpful. They may not know these things, that some videos are there, okay? So try to go through all these things, you practice these things, okay, and try to go along with me. So probably we can at the end of, sorry, by the examination nearly, we can finish all the syllabus up to second year also, okay? So let's see what happens. We try to go through all these things, okay? Okay students, so keep sharing video, okay, like the video, and don't forget to subscribe and share among with your friends, okay? Thank you so much. Thank you.